So our sole purpose of class today is to review for the test. Let's start off. Does anybody have any questions off the homework that we've had from Monday? Okay. So let's just go ahead and we'll start from the top with the simplest and we'll work our way up to the more complex. You know, we started out with reducing fractions. And if I use that key phrase, lowest terms, what that means is simply reduce the fraction. So if we have 21/56, we have to look at that and figure out what can we divide both of those numbers by. 7, very good. So 21 divided by 7 is 3. 56 divided by 7 is 8. So that reduces to 3/8. The biggest mistakes people will make with those is they'll get something like 48 out of 64. And they might see that both of them can be divided by 4. 48 divided by 4 is, oops, 24, yep. Oh wait, no, it is 12. 48 divided by 4 is 12. And 64 divided by 4 is 16. And they'll stop there. But if you look at that closely, you see that both of those can still be divided by 4 again. 12 divided by 4 is 3, and 16 divided by 4 is 4. So it does reduce to 3/4. So if you're doing that, reducing those or putting in lowest terms, make sure you go all the way. Check to make sure there still isn't something you can divide out. You have to convert to mixed numbers or write as mixed numbers. You might have something like 27/5. How do we convert that out? Okay, 5 goes into 27 5 times with a leftover of 2, so it's 2/5. And remember, that's kind of like doing just a long division and a remainder. 5 goes into 27 5 times. 5 times 5 is 25. There's 2 left over, so there's the 2/5 left over. We can go the other way. Convert to an improper fraction. So if I have 3 5/8, how am I going to turn that into an improper fraction? Perfect. 3 times 8 is 24, plus 5 is 29, and that stays 8s. When we're converting from an improper fraction to a mixed number or a mixed number to the improper fraction, the denominator does not change. So then, of course, we'll have our operations with fractions. Add, subtract, multiply, divide. The biggest ones that people will mess up will be with the mixed numbers. So we might have something like 8 7/8 plus 5 3/5. Now for the test, it is okay if you have a fraction calculator to use that fraction calculator. That is allowed. But if you don't, we need to find a common denominator, which will be 40. So then this is going to become what? 35. Good. 8 times 5 to make 40, so 7 times 5 makes 35. This is going to become 24. Good. 5 times 8 to be 40, so 3 times 8 is 24. So then we're going to add. 35 plus 24 is 59/40. That is more than 1. It's an improper fraction, so that's 1 and how much is left over? 19/40. So we're going to keep the 19/40 and carry the 1 whole number. 1 and 8 is 9 plus 5, 14. So 14 and 19/40. Subtraction was similar. We might have 7 1/6 minus 4 3/4. Had to find common denominator again. In this case, it will be 12. This is going to be 2, and this will be 9. So when we go to subtract here, 2/12 minus 9/12 can't be done. So we do have to borrow. This is going to become 6, and this is going to become what? 14. Good. Because when we borrow one whole thing, and the denominator tells us how many pieces are in that one whole. So we have to add the denominator to our numerator. 2 plus 12 is 14. So that is 14/12. 14/12 minus 9/12 is 5/12. 6 minus 4 is 2. So 2 and 5/12. One that I'll see a lot of mistakes on is multiplying mixed numbers. A lot of people will do 8 times 2 is 16, 1/5 times 2/3 is 2/15. That can't be done. How do we do this? Make them improper. So 8 and 1/5 is going to become how many fifths? 41 fifths. 8 times 5 is 40 plus 1 is 41. 2 and 2/3 will be how many thirds? 8/3. Good. So now, if we could cross cancel, we could do that here, but there's nothing that cancels out. So we have to do 41 times 8 is 328. 5 times 3 is 15. Now we have to divide that out. 15 goes into 32 twice. That's 30 with 2 left over. Bring down the 8. 15 goes into 28 once with 13 left over. So that's 21 and 13/15. So we might have something like this. When we divide, where do we start? Make them improper fractions again. So this one's going to become 21/4. 5 times 4 is 20 plus 1 is 21. This will be 18 fifths. Can I cross cancel the 4 and the 18? No, because right now it is still division. Now the first one never changes. It's always the number that comes after the operation that's affected. So instead of dividing by 8/5, this is going to be times 5/18. I said divide by 18/5, we're going to multiply by 5/18. So now we can cross cancel if we want to. 21 and 18 both divide by 3. 18 divided by 3 is 6. And 21 divided by 3 is 7. So 7 times 5 is 35. 4 times 6 is 24. That goes in there once with 11 left over. So 1 and 11/24. What if I have a fraction raised to a power? 3/5 to the power of 6. That's 3 to the power of 6 over 5 to the power of 6. 3 to the power of 6. $729. Okay. 5 to the power of 6. Perfect. So there it is. we didn't do the power of a mixed number, but I'm going to do one here just to show you how it's done. Let's say we have like 2 3/8, and we're just going to square it. We have to change that into an improper fraction, just like we have for multiplying or dividing. So 2 times 8 is 16, plus 3 is 19/8. And now we do 19 squared, which is 381, over 8 squared, which is 64. And we have to reduce it down again. $64 goes into 381. Let's try 5 times. That's 320 with 61 left over. So that's 5 and 61/64. Now again, that's not something we've done. That won't be on the test, just so you know. I'm not mean enough to show you one example and then put it on the test. Yet. Just like on the last test, we are going to have to solve equations yet. These might be a little more complex than the last test. We might have something like 5x minus 7 equals 43. How would I go about solving that? Add 7, yep. So 5x equals 50. And then divide by 5. So x equals 10. Now, being a test, and since I don't restrict you for time, if you need extra time, we'll give it to you. I would recommend you go back and check your answer. So if we're saying x equals 10, I can replace that x with 10. So 5 times x is going to become 5 times 10 minus 7 equals 43. And checking to see that that works out. 5 times 10 is 50. 50 minus 7 is 43. So I do have the same value on both sides of my equal sign. We might have something like this. When we go to solve, remember our process to solve these is we find the equal sign and then we find which side the variable is on. Here we see that the variable occurs twice. But here the variable both times is on the same side of the equation, which means we can do what? We can just combine it. So 7x and 2x make 9x, and of course that's plus 3 is still there. So then what? Minus 3, 9x equals 27, and then divide by the 9. X equals 3. Or you might have something like this. So again, we find our equal sign. We go to identify where the variable is. The variable appears twice again, but this time it's once on each side. So what do we do with that? Get rid of the smaller one, which will be the 5x. It's positive 5x, so we're going to subtract 5x to make it go away. So we're left with the positive 7. We have to subtract 5x from the other side. 7x minus 5x is 2x, and we still have the negative 11. So what is next? We add the 11. 18 equals 2x, and then divide by 2. So 9 equals x, or x equals 9. Again, I would recommend you go back up here and double check that. Instead of 5 times x, that's going to be 5 times 9 plus 7. Equals, on the other side says 7 times x, that'll be 7 times 9 minus 11. 5 times 9 is 45. 47. 45 plus 7 is 52. Over here, 7 times 9 is 63, minus 11 is 52. So we do have the same value on each side. Any questions? Okay. There are going to be word problems. We'll come back to them at the end. Going up the level of difficulty, probably the next step is going to be factoring. If I say factor completely, that's the same thing as prime factor. So if I give you something like 120 and I tell you factor completely, remember this is where we do that factor tree. What's any number that goes into 120? 10. There we go. 120 divided by 10 would be 12. So now we could use 2, we could use 4, we could use 5, we could use 3. We saw the 0 there, so we knew it divided by 10. So that one was really quick. Bless you. So now we look at these. 10 can be divided by what? 2, which would leave us with 5, and both of those are prime. So we're done there. 12 can be divided by 4, and it leaves us with 3. The 3 is prime, so we're going to circle that. The 4, however, can be split into 2 and 2. So those are not prime. So 120 factors into, we have 3 2s, 2 times 2 times 2, and a 3, and a 5. You could write it like that. That is just fine. Or you could write it as 2 to the 3rd times 3 times 5. Either of those is an acceptable answer there. What if I ask you to factor completely something like 54x squared p to the 3rd? We're going to factor the 54 separately, exactly. What's any number that divides into 54? So 9, which should leave us with 6, good. 9 splits into 3 and 3. 6 splits into 2 and 3. So the 54, 2 times 3 times 3 times 3. How about x squared? X times x, you got it? And p to the 3rd? 3 p's. P times p times p. There it is. That's one way you could express it. Or you could do 2 times 3 to the 3rd. Then it would just be x squared and p to the 3rd would still be there. Any questions on factoring? What if I ask you to find the LCM? What does LCM stand for? Least common multiple. Good. So this is going to be bigger than both of the numbers. It is the smallest number that both of them go into. So for our fractions, it was like the least common denominator was a least common multiple. If I give you 8 and 12, what is that least common multiple going to be? 24. Yeah. If you can't find that, what you do is this. You factor them. 8 factors into 2 times 2 times 2. That used to be the factor tree. I'm just skipping that step. 12 is 2 times 2 times 3. And we look at what they have in common. They both have a 2. They both have a second 2. This one has an extra 2, so we need to put a 2 down here. Now they both have that third 2. This one has a 3, so we need a 3 up here. Now they both have the 3. So now they have all their factors in common. 2 times 2 times 2 is 8, times 3 is 24. 2 times 2 times 3 is 12, times 2 is 24. So 24 is the least common multiple. What if I give you numbers like 10x to the 5th, y to the 3rd, and 6x squared y to the 4th? Well, we separate out the numbers. For 6 and 10, what is my least common denominator going to be? There's one smaller than 60. 30 will work. 30 is the least common denominator. Now for the variables, depending on which direction we're going, if we're doing factors or multiples, we either take the smallest or the largest power. For multiples, we take the larger of the powers. So between the x squared and x to the 5th, we're going to take x to the 5th. For the y, we're going to take y to the 4th. Remember when we were doing fractions and looking for least common denominators, if I had 3 over 5x squared y plus 7 over 10xy to the 3rd, our least common denominator was going to be the 10 for the 5 and the 10, but we take the highest power, so x squared and y to the 3rd. I'm going to have you guys try one of those because that's one that seems to get a few mistakes on the test. Find the least common multiple, the LCM, for those two numbers quick. For the numbers 12 and 15, what's the least common multiple? 60. For x, it's going to be x to the 5th and y squared, the highest power of each variable. Now, if we're struggling with that, we can always factor, and we see, okay, we've got 3 in common here. We've got 2 x's, and we've got a y. So down here we've got the 5 and the y, so this has to be multiplied by a 5 and a y. Up here we've got 2 2's and 3 x's. And if we multiply either one of those out, both of them should come out to be 60 x to the 5th y squared. So what if we have something like this? 5 over 4p squared plus 7 over 8p. What's that? Okay, so this is going to have to be 8p squared as our common denominator. So this had to be multiplied by 2, so 5 times 2 will be 10. And this just has to be multiplied by p. 8p times p, bless you. This is the 8p squared, so 7 times p is 7p. So the first thing you had to find there was that common denominator, the 8p squared. So 4 and 8, the least common denominator is 8. For p, the highest power is squared. And this, yeah, had to be times 2, turn the 4p squared into an 8p squared, and times p to turn the 8p into an 8p squared. Now that we have the same name, common denominator, we add the numerators. 10 plus 7p is 10 plus 7p over 8p squared. We might have a subtraction like let's do 5m over 6p minus 7 over 9p. We need our common denominator, which is going to be what? Careful. For 6 and 9, it will be 18. Okay, 18p, right? So what do we have to do to the 6p to turn it into an 18p? Times 3. So the 5m times 3 is 15m. Down here, what do we have to do to the 9p to turn it into an 18p? Times 2. So the 7 is times 2 to make 14. And now we subtract. 15m minus 14 is 15m minus 14 over 18p. What's that? Oh, sure. Yep. The engine additive. When we multiply, I can list it like that, or I could list it without the parentheses. It doesn't matter. Remember, I usually separate out the numbers. What can I cross cancel here? 3 and 9 both divide by 3, which will give me 1 and 3. 8 and 4 both divide by 4 to give me 1 and 2. So 1 times 1 is 1. 2 times 3 is 6. So in my answer, the numerical part is going to be 1 over 6. Now, I might not need the 1 up there, but we're going to put it there for now just in case. Now for the variables, I've got y over nothing times x squared over y squared. So I multiply that out. Y times x squared is x squared y. And on bottom, I just have the y squared. So in my answer, does x go on top or bottom? Top, and it'll have a power of 2. There's nothing to cancel with the x, so just the x squared just stays x squared. The y is going to end up top or bottom? Bottom, and it's just a y. Because the larger power was on bottom, and 2 minus 1 is just 1. So it's just y, or y to the 1, or just y. I could leave the 1 in there. It doesn't affect anything. So 1x squared over 6y. Or I could get rid of the 1 and just make it x squared over 6y. Either one is acceptable. Or we might have a division problem. Okay, we will have a division problem. How's that? Something like 10d over 11x squared divided by 5d cubed over 22x. What's our first step? Oops. So we turn it into multiplication, right? Take the reciprocal of the second one, we flip it over, and now it's multiply. Then what do? Take out the numbers. And what can we cancel? 10 and 5 make 1 and 2. 1 and 2. So 2 times 2 is 2. 1 times 1 is 1. So in my answer, not 2, 4. 2 times 2 is 4. It's one of those days. So in the answer, I have 4 on top and a 1 on bottom. I'm not going to put the 1 on bottom because if there's nothing else down there, this is just going to be, it's not going to be a fraction anymore. So I'm going to pull up the variables. I have d over x squared, and then I have x over d cubed. So I multiply those out. We got dx over d cubed x squared. So what happens with my d, top or bottom? Bottom and a power of 2. Good. 3 minus 1 is 2. X, top or bottom? Bottom, power of 1, or just x. 2 minus 1 is 1. So x to the 1, or just x. So 4 over d squared x. Any questions? So we've taken a fraction to a power earlier. What if we have variables in there? Well, it's still just going to be each piece. 10x to the 4th squared, 5a squared d squared. There was nothing we could reduce inside that fraction. That would always be our first step. Once we've done that, we can do the power to the numerator to that power and the denominator to that power. 2x to the 4th squared. Well, what is 2 squared? 4. X to the 4th squared, x to the 8th. We multiply the powers. 4 times 2. Down here, 5a squared d, all squared. What's 5 squared? 25. A squared squared. Yeah, 2 times 2 is 4, so a to the 4th. And d squared is just d squared. What do you think? Not terrible? What's that? Give it there for a second? Sure. So how about something like this? Where do I start? Perfect. We always look at the parentheses, and this time there's nothing we can do inside there. So then we go to, perfect, we multiply the 7x to the 5th through. We distribute it through. So 7x to the 5th times 9x to the 4th. 7 times 9 is 63. X to the 9th. When we're multiplying exponents with like bases, we add powers. 7x to the 5th times negative 2x squared. Negative 14 x to the 7th. We still have this positive 3x to the 9th out here. Are we done? No. We have x to the 9th and x to the 9th can be combined. 63 and 3 make 66x to the 9th minus 14x to the 7th. Let's have a proportion like this, where I'm asked to solve for x plus 3. Because this is not just the variable there by itself, the easiest way here is to cross multiply and make an equation. So we do 25 times 12, which is 300. Then going this way, we have x plus 3 times 15, or 15 times x plus 3. And we set those two equal to each other. 15 times the x plus 3 has to equal to 300. Nothing to do in the parentheses. So we multiply by the 5. Or 15. 15 times x is 15x. 15 times 3 is 45. Then what? We subtract the 45. So 15x equals 255. And then we divide by 15. 255 divided by 15 is 17. We're running a little short on time, otherwise I'd have you try this one on your own first before we go through it. But what would be the first thing I have to do here to solve? Add the 4.5. So I'm left with 2/3 x here. 3 3/4 plus 4.5 is 8 1/4. I'll leave you to verify that addition, that adds up to 8 1/4. Now what do we have to do? Divide by 2/3. So it's 8 1/4 divided by 2/3. 8 1/4 is going to be 8 times 4 is 32 plus 1 is 33 over 4. I'm going to change this to times 3 over 2. Nothing cross cancels. So 33 times 3 is 99. 4 times 2 is 8. Eight goes into 99 12 times with 3 left over. We might run into problems like this. How would I solve a problem like that? Where would I start? Yeah. This fraction bar means this whole side of the equation has been divided by the 7. So to start out, I'm going to get rid of that, and I'm going to multiply by the 7. So I end up with 2x plus 6 equals 28. Now we had said you could distribute that dividing by 7 as well. You'd end up with 2/7 x plus 6/7. I'd rather not work with the fractions if I can avoid it. So then what? Subtract the 6. 2x equals 22. And then divide by 2. X equals 11. And just like before, we could come back up here and put the 11 in for x and make sure we get the same value on each side. So 2 times 11 is 22. 22 plus 6 is 28 over 7 is 4. You might run into 2/3 x minus 1/4 over 1/3 equals 1.5. Why not? So now what? What do we do with this one? Times 1/3, right? We divided by 1/3, so we're going to multiply by 1/3. So 2/3 x minus 1/4 equals 1 1/2 is 3 halves. Times 1/3, the 3's cross cancel, give me 1 1. So that's just 1/2. Now what? Add a 4th. 2/3 x equals 3/4. And then divide by 2/3. 3/4 divided by 2/3 is 3/4 times 3/2, which is 9/8, or 1 1/8. Yeah. Yeah, that would have canceled it out. I just know dividing by itself cancels out, so I didn't bother to rewrite it that way. So let's say we have 2/3 plus 3/5 times 3/4 squared. What do we have to do first? We have to do the power. 3 squared is 9, and 4 squared is 16. What's next? We have to multiply. 3/5 times 9/16. Unfortunately, there's nothing there that can cross cancel. So 3 times 9 is 27. 5 times 16 is 80. Then what? We're going to add 2/3 plus 27/80ths. Give us a simple common denominator of 240. 3 times 80, so 2 times 80 is 160. 8 times 3 makes 240. So 27 times 3 makes 81. So 160 plus 81 is 241 over 240. So this is 1 and 1 over 240. What do you think? Okay. How about something like this? What's that mean? Yeah, they're just dividing. This is just a different way of writing the problem. Y to the third over 48 divided by y over 24. So, of course, the first thing we're going to do is take the reciprocal and make it multiplication. Now, here you could separate out the numbers, but this is one where probably simplest just to multiply it out and reduce. Y to the third times 24 is 24y to the third. 48 times y is just 48y. And now I can reduce this. I pull out the number. 24 over 48, what does that reduce to? 1/2, right? Both of those can be divided by 24. So I've got 1/2. What was my variable? What happens with my variable? It goes on top because the larger power was on top. And it's going to be a power of 2, because 2 minus 1 is, or 3 minus 1 is 2. So that's going to be 1y squared over 2, or just y squared over 2 would work as well. Well, that is the ugliest of it, pretty much. So, some word problems. If I give you a rectangle that has a length of 3x plus 7 and a width of 2x minus 3, find the perimeter. Well, remember, perimeter is 2 times the length plus 2 times the width. What's the length here? 3x plus 7. So I put in 3x plus 7 there. Plus, bless you. 2 times the width. What's the width? 2x minus 3. So now we go ahead and if you left it like that, couldn't mark it wrong, but we can simplify it. We'll distribute this to 2 times 3x, 6x, 2 times 7, 14. Over here, 2 times 2x, positive 4x, and 2 times negative 3, negative 6. And of course, we can go one more step. 6x and 4x is 10x. 14 and negative 6 is 8. So the perimeter would be equal to 10x plus 8. This is as far as we can go with that. Any questions? No. The other ones are ones that you've seen. Pretty typical. Okay, there is no homework or quiz. All that we have to do is prepare for the test tomorrow. Like I said, if you need any special arrangements, get those made and let me know when you want to take it. You can come grab the test for me. I will be in this room tomorrow from 7:30 a.m. to 2 p.m. So if you want to come in early and start on it, that's fine. The room next door here is empty. If you need to stay after and finish up, if you need extra time, you will have unlimited time to finish the test. Like I said, the only thing I ask is you do it in 2 sittings. So if you have to leave and you're not done, you can come back and finish it later. But when you come back to finish it, you have to finish it at that time. You can't come back 2 or 3 times. Keep working on it. Yeah. I'm pretty sure there's going to be 48 questions on this test. It's a longer one. This is one of the tougher ones because of the variables and stuff in it.